Greetings, dear ladies and gentlemen. I welcome you all to our today's lecture. Today we shall be looking at lecture number 9, which is simply a continuation to our previous lecture, which was lecture number 8. In case you missed one of our lectures, that is from lecture 1 up to lecture number 8, please find the link in the description so you can easily get to know what we have covered so far. So in our previous lecture, we were looking at what we call the expectation, variance, and standard deviation, basically for what we call discrete random variables. So we looked at different examples, and I left you with some of the trial questions. So here were some of the questions that were left behind for you to try, and I believe these questions were not complicated to any one of you. So we shall look at some of the examples to deal with continuous random variables. So we shall begin by looking at example number 1. So example number 1 says a random variable x has the probability density function, which is given as f of x equaling to k into 1 minus x squared, and that one takes the range from 0 less or equal to x less or equal to 1 and 0 elsewhere. We are told that k is a constant. We need to find 1, the value of the constant k, 2, the mean of x, and 3, the variance of x. So let us look at the solution. Let us look at the solution. So we are given that f of x is same as we are having k into 1 minus x squared, and for this takes up all the values of x from 0 up to 1, and 0 that is elsewhere. So that is what we are given. So this is our PDF, and we need to find the value of the constant k. So let us see how best we can do this. In our previous lecture, that was probably lecture number 7, we looked at how we can find the constants, how we can find the probabilities when we are given a PDF. So I believe you still recall some of the procedures that we follow when we are looking for the constants and the probabilities. So let us look at how best we can get the value of k. So we understand that the integral from negative infinity up to infinity of f of x with respect to x, the total area must be equal to 1. So for our case, we are given the interval that is 0 to 1, that is taking this function, but 0 elsewhere. So which implies that we shall have from 0 to 1, that is the given range, because other ranges are equal to 0. So we shall multiply by k into 1 minus x squared, and then dx, and the total area must be equal to 1. So from here, we can simply have k out, and this is 0 to 1 of 1 minus x squared dx, which is equal to 1. And now this will be k times, this will be k times. So we shall integrate this. When you integrate 1, you get x. When you integrate x squared, you get x to power 3 divided by 3. Remember, when you are integrating, you are increasing the power by 1 and dividing by the new power. So if you have x to power 2, when you add a 1 on 2, so it becomes 2 to power x to power 2 plus 1 over 2 plus 1. So increase the power by 1 divided by the new power. So likewise, if you have a constant value like 1, so this is same as 1 times x to power 0. So when you increase this by 1 and divide by the new power, you'll be able to get x. So that is why we are writing this. So this is from 0 to 1, and this is equal to 1. So from here, we shall have this as k. So let us put the upper limit. Where there is x, let us put 1. So this will be 1 minus 1 to power 3 divided by 3, minus, put the lower limit, is 0. So this will remain 0, and this is equal to 1. So from here, we shall have k into, this is 1 minus a third, which is actually equal to 1. So this is same as k times 1 minus a third, that is 2 over 3, which is equal to 1. So k will be same as 3 divided by 3 divided by 2. So therefore, the value of k is 3. Therefore, the value of k is 3 divided by 2. So from there, we shall be able to obtain the value of k. So having obtained the value of k, this means, this implies that our f of x now will be 3 divided by 2 into 1 minus x squared. The range is from 0 up to 1. So 0 elsewhere. So this becomes our f of x after substituting for the value of k. So part 2, we need to look at the expectation of x. We need to look at the expectation of x. So that is the mean of x. Mean of x is same as the expectation of x. So the expectation of x by definition is same as the integral from negative infinity to infinity of x times f of x dx. So looking at this, it means we need the expectation. Our given range is from 0 to 1, and other ranges will be taking 0. So you're having 0 plus the integral of x times the f of x. So that will remain as 0 to 1. F of x is 3 divided by 2 of 1 minus x squared dx. So that is how we obtain the mean. So we get x times f of x. But since this is our f of x is known, we shall substitute for it. Then our limits we are considering from 0 to 1. So all other limits will be giving you 0. So that's why we have not considered them. But in other words, this should have been written as, in general, you are supposed to write this as from 0 0 to negative infinity of f of x dx, and then plus from this should be, so in general it should be from negative infinity to 0, then 0 to 1 f of x, actually there is x here, then dx, then plus from 1 up to positive infinity x f of x dx. But of course this one is 0 because of this 0 elsewhere, this is 0, so we only remain with this. That's why we are writing this. So from here, this is same as having 3 divided by 2 into x, which is into 1 minus x squared, and then dx. This is from 0 up to 1. So this is same as having 3 out of 2, integral from 0 to 1 of x minus x to power 3, and then dx. So from here, this is same as having 3 over 2. Now integrate this. This is to power 1. So increase the power by 1, divided by the new power. This will be x to power 2 divided by 2. Increase the power, divided by the new power, x power 4 divided by 4. This is from 0 to 1. So substitute. Put your limits. So we shall begin with the upper limit. Put where there is x, put there 1. So this is 1 squared over 2 minus 1 to power 4 over 4, then minus 0. So try to simplify this. So this will give us a quarter. So when you multiply that, that will be 3 out of 8. So our expectation will therefore be, the mean of x is, 3 divided by 8. So that will be the answer. So next, the next part, we need to look at the variance of x. So 3, let us talk about variance of x. So what will be the variance of x? By definition, a variance of x is defined as the expectation of x squared minus the expectation of x, the whole of this squared. If you recall from our previous lecture, we proved this one here, and you should be able to know how this one comes about. So it means we need to first of all consider e of x squared. So the expectation of x squared, as we look at the expectation of x, so we look at negative infinity to infinity of x squared, then f of x dx. That is taking up all the ranges. But for our case, our range is from 0 to 1. So from 0 to 1 of x squared times f of x. We already have our f of x, which is 3 over 2 into 1 minus x squared, then dx. So this will be same as 3 out of 2, integral from 0 to 1. I want to multiply this one here, so it gives us x squared minus x to power 4, and then dx. So this would be 3 by 2. Integrate, increase the power for this, it becomes x to power 3 divided by 3, minus this is x to power 5 divided by 5. Then the whole of this we subtract when we put the lower limit, which is 0, and we shall basically be having that. So this will be same as having 3 by 2 into, put the limits. So we are having the limits from 0 to 1. So put 1, this will be a third, 1 to power 3 minus 1 to power 5 divided by 5, and we are subtracting 0. So this will give us 3 by 2 into a third minus 1 over 5. So that is same as 3 over 2 into the LCM is 15. divided by 3, 5 minus 3. So this will give us 3 over 2 times 2 over 15. So by 2 goes, this is 1, this is 5. So this will give us 1 divided by, this will give us 1 divided by 5. So this implies that the expectation of x squared is same as 1 divided by 5. So having gotten the expectation of x squared, we already know the expectation of x. So we shall now substitute to get the variance. So variance of x will be same as we have seen, it is expectation of x squared, expectation of x, the whole of this squared. So this is same as 1 over 5 minus 3 over 8, the whole of this squared. 3 over 8 is our expectation of x. So the mean of x is 3 out of 8. So this will give us 1 over 5 minus 9 over 64. So get 1 over 5 minus 9 over 64. So this will be able to give us 19 out of 320 as the variance of x. So therefore, we can say that the variance of x is 19 out of 320. So that will be the value of the variance of x. So from there, we shall have our example number 1 answered. So our example number 1 will be answered. We have got the value of the constants, we have got the mean and the variance, and I hope the procedures of getting the mean, getting the variance for a continuous random variable are very clear to everyone. So we shall look at our example number 2. So this is our example number 2. Let us now look at example number 2, which says a random variable x of a continuous PDF is given by, so we have our f of x, which is equal to this, and we need to find mean, standard deviation, and this probability. So let us look at the solution. So we are given f of x at 3 over 4 into 1 plus x squared, and we are given that x takes on all the values from 0 up to 1, and also we are given that 0 is where. So we need to find mean, and we have already seen how we can get mean. So part 1, we need to look at mean. So mean, that is mu. By definition, that is same as integrating x times f of x dx. But looking at what we have as our limits, we have from 0 up to 1. So we shall have this as from 0 to 1 of x times 3 over 4 into 1 plus x squared dx. So we shall have this as 3 over 4 into, so that is the integral from 0 to 1. We shall multiply x here, so we can have x plus x to power 3, then dx. So this is same as having 3 over 4. So now let us integrate this. This will be x squared divided by 2 plus x to power 4 divided by 4. As I said, when we are integrating, we increase the power by 1 and divide by the new power. So from there, we shall go on and substitute the limits. So we shall begin with the upper limit. Where there is x, we shall put 1 squared over 2, plus we shall have 1 to power 4 over 4, and we shall subtract the lower limit. The lower limit is 0, so 0 substituted here will remain 0, substituted here will remain 0. So this will be 3 over 4 into half plus a quarter, and a half plus a quarter is 3 quarters, so we have 3 over 4 times 3 over 4, and this will give us 9 over 16. So we have got the value of a mean as 9 over 16. So next we need to look at the standard deviation. So let us look at standard deviation. So standard deviation comes from taking the square root of variance. So what we need to do first is to look at variance. Then after getting variance, we can easily get a standard deviation. So here we can lastly say, therefore, mean is 9 over 16. So we need to get the variance in part 2. So in part 2, we need to get the standard deviation. But as I said, standard deviation comes from variance, because we know standard deviation by definition is same as the square root of variance. So which means we need to get variance first. So let us now look for variance. So for variance, a var of x is same as expectation of x squared minus expectation of x, the whole of this, which is squared. So now let us first of all get the expectation of x squared, since we already have expectation of x. So expectation of x squared, as we have already seen, is same as integrating x squared times f of x dx. But here we have our limits from 0 up to 1. So this will be same as having integrating from 0 to 1 x squared times f of x, which we have as 3 over 4, into 3 over 4 into 1 plus x squared, and then dx. So this will be same as having 0 to 1. 3 out of 4 can be out. Then this will be x squared plus x to the power of 4 dx, as we multiply this one inside here. So this will be 3 over 4. We can now integrate. This will be x to power 3 divided by 3 plus x to power 5 divided by 5 from 0 to 1. So this will be same as having 3 over 4. Now we shall put the limits. This will be 1 to power 3 divided by 3 plus 1 to power 5 divided by 5. We shall subtract when we put the lower limit, but the lower limit is 0. So this will be same as having 3 divided by 4 times a third plus 1 over 5. So get a third plus 1 over 5, and this will give us, so this will give us 8 over 15. So this means that we shall have 3 over 4 times 8 over 15. And this will be same as, by 3 is 1, by 3 is 5, by 4 is 1, by 4 is 2. So we shall have 2 out of 5. So this is the expectation of x squared. So expectation of x squared will be that. Now, having gotten the expression for that, remember we are interested in variance. So what will be variance? So variance of x will be same as 2 out of 5 minus. So we had got 9 over 16. So this is minus 9 over 16 squared. So we shall have this as 2 out of 5 minus, so let us get 9 out of 16 squared. So we get 9 divided by 16 squared. Then we get 2 out of 5 minus. So this is giving us 81 over 256. So this will be same as 2 minus that answer, which will give us. So this will give us 107 out of 180 as the variance of x. So having gotten the variance of x, we can now look at standard deviation. So what will be standard deviation? So standard deviation is the square root of variance, which is 107 divided by 180. So we shall get the square root of that answer, and that will give us 0.289125.837. So therefore, you can simply say standard deviation. Therefore, standard deviation is, so we can have this as 0.2891, 4 decimal places. So this is to 4 decimal places, and that will be standard deviation. So next, let us look at part C, so which is requiring us to get probability of magnitude of x minus mu, then less than the standard deviation. So let us look at that solution. So part 3, so we need the probability of x minus mu, and then this is less than rho, which is the standard deviation. So this one here is same as the probability of magnitude of x minus this one here, we got it as 9 over 16. So that is same as 0.5625. And then this one here is less than the standard deviation. We have got the standard deviation 0.2891, 0.2891. So that is the probability we are interested in. So this probability here is same as having So before we come to this, let us first look at if you are having magnitude of x less than, for example, 2. So this one here is same as minus 2 less than x less than positive 2. So magnitude of x less than 2, it means you can have it as negative 2 less than x, which is less than 2. Because magnitude of a number is same as a positive of that number provided x is greater or equal to 0, and negative of that number provided x is less than 0. So for that case, if you have a magnitude of x less than 2, then it means you can have this as negative 2 less than x less than 2. So that is as what we shall be using. That is basically what we shall use. So if that is the case, then this can be treated as the probability of negative 0.2891 less than x minus 0.5625 less than 0.2891. So having that, this is still same as bringing this one this side and taking it to that side. So when you have that, so when this one comes here, it becomes a positive. So negative 0.2891 plus 0.5625 less than x less than 0.2891, add there still 0.5625. So looking at that, this is same as probability of, so we shall get negative 0.2891. Then we add there this, which will give us 0.2734 less than x less than, so we get 0.2891. We add there 0.5625. So that will give us 0.8516. So that is the probability we are interested in. And of course, in our last lectures, we looked at how we can get such probabilities. So looking at the range we are having, you realize that these values here lie within this given range. They lie within the range of 0 up to 1. So it means we shall still use this given function. So let us look at this probability. So this will be same as having the integral from 0.2734 0.8516. Then we shall integrate f of x, but our f of x is 3 out of 4 into 1 plus x squared dx. So this is 3 out of 4 integral from 0.2734 to 0.8516 of 1 plus x squared dx. So from here, we shall integrate. From this given point, we shall now do integrate. So let us integrate. So when we integrate, this will be same as having 3 out of 4 into, so we are having x plus x to power 3 divided by 3 from our limits 0.2734 to 0.8516. So this will be 3 out of 4. Put the upper limit 0.8516 plus 0.8516 to power 3 divided by 3. So the whole of this we need to subtract 0.2734 plus 0.2734 to power 3 divided by 3. So that will be that is what we shall get after substituting. So this will be 3 out of 4 into, so let us try to manipulate this. We manipulate this, then we try to subtract. So manipulating this, it will give us 1.0575. So we are subtracting, so we now put for 0.2734, then we add there that, so it will give us 0.2802. So from there we shall get 1.0575. We subtract 0.2802. So that should be able to give us that should be able to give us a 0 point. So 3/4 times 0.7773. So we multiply by 3/4, and that will be able to give us the value as a 0.582975. So therefore, we shall have the probability of x minus mu, which is less than the standard deviation, to be 0.5830. That is to 4 decimal places. And that will be the answer. So basically, that is what we shall get per example number 2. So I hope example number 2 is very clear to everyone. And please, in case you haven't subscribed to this channel, kindly do so. Subscribing is completely free of charge. It is simply a way of appreciating the work, and you will always get notified whenever a new video is uploaded. So don't forget to share, like, and comment on this video. So let us look at the next example. So this is our example number 3. Now, looking at example number 3, it says a random variable x of a continuous PDF is given by, so this is our f of x, which is k of x. K of x is a function which is taking up all the values of x from 0 to 1, and k into 2 minus x is taking up all the values from 1 up to 2. Then other ranges will be 0, that is 0 elsewhere. So we need to find 1 at the constant k, expectation of x, variance of x, variance of 2x minus 6, then the probability of 0.75 less x less 1.5. So that is what we need to look at. So we shall look at the solution. Now we are given our f of x as, so this is example number 3. So we have f of x, which is given as, so this is k of x, 0 less or equal to x less or equal to 1. We have k into 2 minus x, taking up values of x from 1 to 2. So we need 1 that obtain the value for the constant k. So part 1, we need the value of k, but how do we get 1? We get a k by looking at the given ranges. So the first one is from 0 to 1 of k of x dx, plus the second one taking up from 1 to 2 of k into 2 minus x dx, but the total area under this curve here should be equal to 1. The total area must be equal to 1. So from here we can have this as k from 0 to 1 of x dx, plus we can also pull out the k 1 to 2 at 2 minus x dx, and this will give us 1. So from here we shall integrate x with respect to x. That will be x squared divided by 2. Increase the power of x by 1 and divide by the new power. So put your limits plus k, do the same here. This is 2x minus x squared divided by 2 from 1 to 2, which is equal to 1. So from here, we shall have this as k. Let us put the upper limit. When you put the upper limit, it will be 1 squared divided by 2. Minus the lower limit is 0, so it remains 0. Then plus this is k into, we begin by putting the upper limit, which is 2. 2 times 2 minus 2 squared divided by 2. Then minus put 1, lower limit, 2 times 1 minus 1 squared divided by 2. And this should be equal to 1. So this will give us a half k. 1 squared divided by 2 will remain that, plus k into, this is 4, minus this is 2 squared, which is 4 divided by 2 is 2. And then we are subtracting 2 minus a half, and everything should be equal to 1. So from there, let us go on and have this. This is a half of k plus k into, this one here is 2. This is 2 minus a half. So 2 minus a half will give us 2 minus a half. It will give us 3 by 2. 3 by 2, which is equal to 1. So this is same as having a half k plus this is 2 minus 3 by 2, which is a half. So that is k times a half, which is equal to 1. We shall multiply through by 2, multiply through by 2. So by 2 here, by 2 there, by 2 there. So this will give us k plus k, which is equal to 2. So 2k will be equal to 2, and k will be equal to 1. So that will be the value of k. So therefore the value of k is 1. Therefore, the value of k is 1. So having gotten the value of k, we can therefore say, therefore our f of x will become, let us have f of x, it was kx, so it will remains x from 0 less or equal to x less or equal to 1. It becomes k into 2, but k is 1, so this will be 2 into, this will be 2 minus x from 1 less or equal to x less or equal to 2, and 0 elsewhere. So that will be the expression for f of x. So next we are interested in getting expectation of x. So let us look at part 2. Part 2, we need to look at expectation of x, or mean of x. So that is expectation of x. So by definition, expectation of x is same as integral from negative infinity to infinity x times f of x dx. So for that case, we shall have expectation of x to be, our first range is from 0 to 1, so it will be from 0 to 1, x times f of x, which is x, and then dx, plus our next range is from 1 to 2, x times f of x, there is 2 minus x, and then dx. So this will be same as having 0 to 1, x squared dx. We add there integral from 1 to 2 of 2x minus x squared dx. So this will be same as having, we shall integrate this. This is from, so x squared, increase the power, it becomes x to the power 3 divided by the new power, which is 3, as 0 to 1, plus do the same here, increase the power of x, that will be x squared divided by 2, which will remain x squared. So this 2 will be x squared divided by 2, so there is a 2, that 2 will cancel. So minus a third, x to power 3, from 1 to 2. So this will give us, put the limits, put 1 there, it will be 1 to the power 3 divided by 3 minus 0. Then we shall add there, put 2, so it will be 2 squared minus a third times 2 to the power 3. This we shall subtract, put 1, this will be 1, minus put 1, this will be a third. So that is what we shall have. So this is a third. plus, so this is 4 minus this is 8 over 3. Here we are subtracting 1 minus a third, that is 2 over 3. So this will be same as a third plus this is 12 minus 8. So 12 minus 8, that is 4 by 3 minus 2 by 3. So this is a third plus 4 by 3 minus 2 by 3. So this will be 2 by 3. So from there, we shall get a third plus 2 by 3. And this will also be equal to 1. So we shall have the expectation of x also equal to 1. So this is equal to 1. So therefore, expectation of x will be equal to 1. So we have got the expectation of x, and next we need to get a variance of x. So we look at variance of x. So let us talk about part 3, where we are looking at variance of x. By definition, variance of x is same as expectation of x squared minus the expectation of x. And this should be squared. So we already have the expectation of x. So we need to look at the expectation of x squared. So expectation of x squared, by definition, it is from negative infinity to infinity x squared times f of x at dx. As we did for expectation of x, so expectation of x squared will be, we begin with our limit. We have from 0 to 1. So that is x squared times the function is x, then dx, plus the next is from 1 to 2. Then x squared times the function, which is 2 minus x dx. So let us deal with this. This is same as from 0 to 1, x to the power 3 dx, plus from 1 to 2. So this is 2x squared minus x to the power 3 dx. So next, when we integrate, this is 1 over 4 x to the power 1 over 4, then x to the power. So this will be to the power 4 from 0 to 1. Then we shall add there. This is 2x to the power 3 divided by 3 minus this is a quarter x to the power 4 from 1 up to 2. So let us put the limits. When you put 1, this will remain as a quarter times 1 to the power 4, then minus 0, and then plus. So here we shall begin by putting 2 over 3 times 2 to the power 3 minus a quarter times 2 to the power 4, then minus 2 over 3. When we put 1, it will remain 2 over 3, minus put 1 here, it will remain a quarter. So that is what we shall have. So this will be same as a quarter plus, so this will be 2 over 3, 2 times this is 16 divided by 3. This is 2 to the power 4, that is still 16. So this is minus 16 over 4. Again, this we shall subtract 2 over 3 minus a quarter. So let us try to simplify that. So this will be a quarter plus 16 over 3. 16 over 3 we shall subtract 2 over 3. Then we shall have minus 16 over 4. Then minus minus, it will be plus 1 over 4. So I'm having 1 over 4 plus this one here, the LCM is the same. So I will simply subtract this and this, which is 14 over 3. And then this with this, I can see this is minus 16 plus 1, that is minus 15 over 4. So this is same as having a quarter minus 15. This is minus 14 over 4, and then plus 14 over 3. So we'll get 14 over 3 minus 14 over 4. So that should be able to give us the expectation of x squared. So we have 14 over 3 minus 14 over 4. So that will give us a 7 over 6. So therefore, the expectation of x squared is a 7 over 6. So having got that, then next we shall talk about the variance. So let us look at variance. but we know that variance of x is expectation of x squared 7/6 minus mean squared, which is 1 squared. So this is 7/6 minus 1. So get 7/6, subtract 1. So when we subtract 1, we shall get 1/6 as the variance of x. So therefore, variance of x is 1/6. So next we need to look at variance of 2x minus 6. So what will be the variance of 2x minus 6? So that is part 4. That was part 4, variance of 2x minus 6. So let us talk about that. Variance of 2x minus 6. So from the properties of variance, this should be able to give us 2 squared times variance of x. Okay, so this is a 4 times variance of x, which is 1/6. So by 2, this will give us 2 divided by 3. And that will be the answer. So that will be the variance. And lastly, we shall talk about the probability of 0.75 less x less 1.5. So this probability here, 0.75 lies within this range, but 1.5 lies within this range, which is above 1. So it means we shall move from 0.75 to 1, then from 1 to 1.5 using the respective functions. So this 0.75 to 1 lies within this range, so it means we will consider this. Then 1 to 1.5 lies within this range, so it will consider this function. So that is what we are going to do. So we shall have, let us talk about the probability. Let us talk about the probability of 0.75 less x less 1.5. So this would be same as integrating from 0.75 to 1 using the function x. And then also integrate from 1 to 1.5 using the function 2 minus x and x. This is what we shall be doing. So don't integrate directly from 0.75 to 1.5, because from there we have different functions. So you must be careful. So you have to choose from 0.75 to 1, and that function is x. Then from 1 to 1.5, there is another function. Let us look at that. So from here, you realize 0.75 lies here, but of course from 0.75 to 1, the function is x. Then from 1 to 1.5, the function is 2 minus x. So you must consider the respective functions. So from here, I shall try to now integrate this and get the answer. So when you integrate that one, it will be x squared divided by 2 from 0.75 up to 1 plus this will be 2 minus 2x, integrating 2 becomes 2x minus x squared divided by 2. So our limits are from 1 to 1.5. So our limits are from 1 to 1.5. So this will be same as put the limits, put the upper limit. You put the upper limit, you will get 1 squared, which is 1/2. Then minus 0.75 squared over 2. So as put the upper limit here, this is 2 times 1.5 minus 1.5 squared divided by 2. Then we shall subtract 1. This is 2 minus put 1 here. This is 1/2. So that is what we shall have. So let us simplify this and get the answer here, and here. So this will give us 0.21875. Then we shall add there. Let us manipulate this, and this will give us 1.875. So we subtract, this is 2 minus a half, which is 1.5. So let us manipulate that. So we have 0.21875. We add there 1.875. We subtract 1.5. And that will give us the answer. That will give us the answer as 0. So it will be as 0.59375. which is actually same as having 19 over 32, which is same as having 19 over 32. So therefore, the probability of 0.75 less x less 1.5 will be equal to that. So from there, we shall have answered this question here. So we wanted constant, expectation, variance, and the probability. So that is what was required from there. So that is basically what we shall have on the expectation and variance for a continuous random variable. And now I will give you some of the questions to try out. So here are some of the trial questions, and please make sure you try them out. So this is our question 1, which says a random variable x of a continuous PDF is given by that. So you need to find k, you need to find expectation, then expectation of that, then plus probability. Please make sure you try out these questions here. Then that is, I hope it is clear. So please put it down, try it on your own, and see if you are able to get the answers. In case of any challenges, don't forget to put them in the comment section so I can address them in our next lecture. So this is our trial question 1, and here is trial question number 2. Here is trial question number 2, which is actually similar to what we have done already. So this is trial question number 2. So I hope this is also okay. Please put it down, try it, try to get the answers. So you will try out this question as well. That is question 3. It says a random variable x of a continuous PDF is given by that. So you need to show that k2 is equal to 3k1. And the next, you need to find the value of k1 and k2, mean, variance, and the probability. So that is our last question. And after that, we shall look at what we call the binomial distribution. So you make sure that you try these questions here. And in case of any challenges, please don't forget to put it in the comment section so I can address it in our next lecture. So let us look at binomial distribution. We have so far talked about the two types of distributions, that is the discrete probability distribution and what we call the continuous probability density functions. So we want to look at some different types of these distributions, and we shall begin with binomial distribution, which is one of the examples of what we call the discrete probability distributions. So let us talk about binomial distribution. So we shall be saying that a binomial distribution is simply a special type of discrete random variable in which an experiment gives rise to only two outcomes. That is either success or failure. So, but there are two outcomes. Either you have success or failure. So we look at some of the conditions for a binomial distribution. So these are some of the conditions. One, the experiment has got a finite or repeated number of trials, n. The trials are independent. The outcome of each trial is either a success or a failure. And the probability that we shall be calling P of a successful outcome is constant for all trials. So those are some of the conditions that a random variable which is following a binomial distribution will have to satisfy. So we shall talk about the notation for the binomial distribution. So if you have a discrete random variable x, which is corresponding to the number of successful outcomes in any trials, and it satisfies the above conditions, then we shall be saying that x follows a binomial distribution. It will be denoted by x follows. This one indicates follows. So x follows a binomial distribution, but we shall be using these parameters n and p. So this n represents the number of trials, and p represents the probability of a successful outcome. So you can have x follows b of n of p. So whenever it is written b, then into some given values, the first one represents the number of trials, and another one represents the probability of a successful outcome. Or you can have it as x follows bin of n p. So this one also represents binomial. So, but in most cases, we shall be using this given expression. Okay. So next we shall have the formula for binomial distribution. So if x follows a binomial distribution, so you're having the number of trials and probability of success, then the probability of obtaining other successes in any trials will be given by P of X equaling to R. So out of the trials, we need to know how many are the successes. So if we have, or we need R successes in any trials, then it will be P of X equaling to R will be same as any combination R. So this will be treated as n combination R. So this is same as having n combination R times P to power R, then times Q to power n minus R. So this one here, it means any combination. And this, you can easily get it from your calculator. If you want to put any combination, for example, 5 combination of 3, 5 combination of 3, then you simply go to your calculator, place 5. Then after pressing 5, you press shift, then division sign. I said you press shift, then division sign. So when you press shift division sign, it will bring you this sign here for combination. Then you put the 3 if you need combination 3, and that should be able to give you something like 10. So if you are talking about any combination R, you can easily get it from your calculator. So that is how we put the combination. So P of X equaling to R will be same as n combination R times P to the power of R, then times Q to the power of n minus R. So that is how we shall be relating P. Q represents a failure, and Q is same as 1 minus P. It means if you know P, then you can easily get Q as well. So R can take up values from 0, 1, 2, and so on up to the nth term. So it means if we are talking about P of X equaling to 2, but we are picking from any trials and the trials are 6, then it means your R will be taking up from 0, 1. So here we need P of X equaling to 2. So it means your R will be 2. It means your R will be 2. But if it is like less than or equal to that, then it means your R will take up from 0 to up to 2. So 0, 1, and 2. So if it is greater than that, then it means your R will take from 2, 3 up to the last term, which is n. So we shall look at all this. We shall look at all this when we are trying to look at some of the examples. But this is basically the expression we shall be using when we are talking about the binomial distribution. Okay, so what majorly we need to remember about binomial distribution, we need to know that it is simply discrete probability distribution which has got a countable domain. So which means that this experiment here, the binomial experiment, is characterized with only repeated trials and 2 possible outcomes. So one we have seen is what we call the success, and that will be denoted by P, and another is what we are calling a failure, and that is denoted by Q. But the two are related in a way that P plus 2 is equal to 1. So it means if you know P, you can easily get Q. Okay, so having looked at that, let us now talk about some of the examples. Also, it is important to note that P lies between 0 and 1. This probability here lies between 0 and 1. Of course, we know a probability of any event lies between 0 and 1. Probability cannot be negative and it cannot exceed 1. So also, likewise, P lies between 0 and 1. Or it can be 0 and it is possible to be 1 as well. Okay, so having looked at that, let us look at some of the examples to understand better how we can use some of these expressions. So let us talk about the examples. So we shall look at our example number 1. Example number 1 says the random variable x is distributed b of 7 and 0.2. We need to find probability of x is equal to 3, probability of 1 less than x less than or equal to 4, and probability of x greater than 1. Now let us look at the solution. When you are given b 7 of 0.2, this means that your n is 7, your p is 0.2. So you are given that x follows b of 7 and 0.2. So by the formula that we have seen, so if x follows this, we know that x follows b of n, then p. So this means that your n is 7 and your p is 0.2. So that is what we are looking at. So if p is 0.2, then you can get q by getting 1 minus 0.2, which is equal to 0.8. So by definition, p of x equaling to r is same as n combination r, and then times p to power r times q to power to power n minus r. So for that case, we shall have this as n. Your n is 7, combination r, your r now. For our case, we want to look at p of x equaling to 3. So our r is 3. So it means the 7 combination 3, and then p is 0.2 to power 3, and then times q, which is 0.8 to the power of 7 minus 7 minus r. So that is 7 minus 3, and that is 4. So we shall have this. We shall have that. So we have 7 combination r times 0.2 to power 3 times 0.8 to the power of 4. So here is what we are looking at. So we have been given that x follows b of 7, then 0.2. As we have seen, then this implies that your n is 7, your p is 0.2, and for that case, q will be 1 minus 0.2, which is 0.8. So what you are interested in is the probability of x equaling to 3. You are interested in the probability of x equaling to 3. So the probability of x equaling to 3, this is our part 1. So it means that your r, for this case, you are looking for r equaling to 3. But we know, if by definition or by the formula, probability of x equaling to r in binomial distribution, same as n combination r times p to power r times q to power n minus r. So it means if you are looking for x equaling to 3, it will be 7 combination 3 times p, which is 0.2 to power 3, and then times q, which is 0.8 to the power of 7 minus 3. So 7 minus 3 is 4. So that is what you will have. So this one on the calculator, 7. Then to put the combination, press shift, then division sign, press 3, then multiply by open brackets 0.2 to power 3, then multiply by open brackets 0.8 to the power of 4. So that should be able to give us 0.114688. So probability of x equaling to 3, we can have it 4 decimal places as 0.1147. So this will be the value for the probability of x equaling to 3. So probability of x equaling to 3 will be equal to that. So probability of x equaling to 3 will be equal to that. So having got that, let us look at part 2. Part 2 requires us to get probability of 1 less than x less than or equal to 4. So let us also look at the solution. So looking at part 2 we are having, so part 2, we need to obtain the probability of 1 less than x less than or equal to 4. But this is same as having the probability. So x equaling to 1 is not part of this, so it will be probability of x equaling to 2 plus the probability of x equaling to 3 plus the probability of x equaling to 4. So out of this, this is same as having x equaling to 2. X equaling to 2 is same as having r as 2. So any combination r, so our n is still 7. So 7 combination r is 2. And then we multiply by the p is 0.2 to power r, which is 2. Then we multiply by 0.8 to the power of 7 minus 2, and that is 5. So we add there, for this one here, is 7 combination 3, 0.2 to the power of 3, 0.8 to the power of 7 minus 3, which is 4. And lastly, we add there 7 combination 4, 0.2 to the power of 4, 0.8 to the power of 7 minus 4, which is 3. So we need to get the values for this. So one of the easiest ways of computing this is we can do this. So go to your calculator, S7, you can see these values are the ones which are changing. These ones are the ones which are changing. So you can have 7, so put 7 combination. So the combination that is a shift, and then division, then press there x. Press here x, then times, press x is the you press alpha, then x. For those who are having Casio, you can do this. Then press times, we are using the x on the calculator, which is like that. Then times, put the multiplication sign, open brackets, put 0.2, close brackets, close brackets. When you close brackets, then this is supposed to be to power, then put that power there of, so this one is our x. Remember, if this is 2, this will be 2. So this will also be x. So press again x, shift, then press x there. So actually it should be alpha, then brackets, press x. Then times 0.8 multiplied by, open brackets again, 0.8, close brackets, to the power, to this power here, open brackets, then it is 7 minus x. Open brackets, 7 minus x. 7 minus x. Then close brackets. Now go to solve where there is curve. So go to solve. When you press, it will bring you x is equal to. Now press your x. Now your x is equal to 2. Press 2 first. X is equal to, then press 2. When you press 2, press equal signs. It will give you 0 point. This will be 0.27525. 275,251. So round off to 4 decimal places. So that will be 27, then 5. So this is a 5. So 5, if the number you want to round off is an even number, then it remains the way it is. If it is an odd number, it increases by 1. But even if you increase this by 1, you will still have relatively the same answer. So next, don't remove that expression. Again, press solve. It brings this x dash. The next we need 3. So press x as 3. It will give you a 0.11, then 4,688. So that will be 47. And then add there. Then next go again to x. It brings again this. And then press there. Now 4. So when you press 4 there, it will give you 0.028,672. So this will be rounded off, and it becomes that. So from there, simply add that. Simply add that. And when you add, you should be able to get the value of that. So the value when we add, it should be around 0.4186. So therefore, that will be the probability of 1 less than x less than or equal to 4. So it will be 0.4186. And that will be your answer. So next we'll look at the next part. So the next part is probability of x greater than 1. So let us look at probability of x greater than 1. So part 3, we need the probability of x greater than 1. So probability of x greater than 1 is like x, probability of x equaling to 2, to 3, to 4, to 5, to 6, up to 7. But that will be a bit hectic to compute. So what we do, so getting the probability of x greater than 1, we can say this is same as the probability of this one here is same as 1 minus the probability of x less than or equal to 1. So if we need the probability of x greater than 1, then we can get it by getting 1 minus the probability of x less or equal to 1. So when we get 1, because we know the total probability must be 1. So it means if we need the probability of x greater than 1, it will be same as 1 minus the probability of x less or equal to 1, which you can have easily as the probability of x equaling to 0, then plus the probability of x equaling to 1. So this is same as having 1 minus the probability of x equaling to 0. From the formula for binomial distribution, this is 7 combination r, which is 0 times 0.2 to power r, 0 times q to power 7 minus 0, which is 7. And then plus 7 combination 1, 0.2 to power 1 times 0.8 to the power of 7 minus 1, which is 6. So let us compute this 1 minus. So we shall use the same formula, or else you can put it there individually. But if you still recall 7 combination, put your x there, multiply by 0.2 to the power of x, multiply by 0.8 to the power of 7 minus x. So your x will be 0. So when your x will be 0, you solve for that. For x equaling to 0, you should be able to get 0 point. You should be able to get a 0.0. 2,097. Then we add there, so you solve for 1, for x equaling to 1, and it will be able to give you 0.3670. So that is what we shall obtain. So this will be same as 1 minus that answer. So when you get 1 minus the whole of this, we can do it at once. 1 minus that. So this will be able to give us 0.4233. And that will be your answer for probability of x greater than 1. So example number 1 will be done. So we can look at example number 2. So basically, that is the solution for example number 1. So we look at example number 2. Example number 2. It says at Freedom City Supermarket, 60% of the customers shop on Saturday. Find the probability that a randomly selected sample of 10 customers, then 1, exactly 2 shop on Saturday, more than 7 shop on Saturday. So looking at this, you realize that you are told that 60% of customers shop on Saturday. So it means your P, if you are to look at, because you were asked to get the probability that in a selected sample of 10 customers, exactly 2 shop on Saturday. So your success is 0. The probability of success is 0.6, or the 60%. So looking at this, we shall have this as, so we are looking at example 2. So we are having P, our success of getting a person who is shopping on Saturday is 0.6, which means Q is 1 minus 0.6, which is 0.4. Then we are given a sample of 10 customers, so that is our N. Our N is 10. So part 1, what do we need? We need to get the probability. So here we are having that X follows a binomial distribution of N, which is 10, and P, which is 0.6. So it means our X, we need the probability of X equaling to exactly 2 shop on Saturday. So if they say exactly 2 shop on Saturday, we need a probability of X equaling to 2. So by definition of this is same as any combination. N is 10, combination R is 2. Then times P is 0.6 to the power of R is 2. Then times 0.4 to the power of n minus 2, which is 8. So this is exactly what we need. So compute that, and it should be able to give us 0.0106. So put that one on the calculator and confirm. So next we need to look at more than 7 shop on Saturday. So more than 7 shop on Saturday, we shall come here. So that is probability of X greater than 7. So probability of X greater than 7, it means since your N goes up to 10, since your N goes up to 10, it means we are saying N goes up to 10. So when we are looking at probability of X greater than 7, so you are simply looking at X equaling to 8, X equaling to 9, and the probability of X equaling to 10. So from there, probability of X equaling to 8, by definition of probability of X equaling to R, is same as N combination R times P to power R times Q to power N minus R. So here your R is 8, here your R is 9, here your R is 10. So it means you have 10 combination 8, then times 0.6 to power 8, then times 0.4 to power 2, plus 10 combination 9, 0.6 to power 9, 0.4 to power 1. 10 combination 10, 0.6 to power 10, 0.4 to power 0. So that is what we are having. So as I said, you can easily put this one at once on your calculator to avoid putting this individually. So what you do, put 10 combination, use unknown X, then multiply by 0.6, it will be to the power of X. Then again multiply by 0.4, it will be to the power of X, it will be to the power of 10. 0.4 will be to the power of 10 minus X. So your X is like your R here. Your X is like your R. So you have 10 combination R times P to power R, then Q to power N minus R, but your N is 10. So here you have 10, it will remain the same 10. So you have 10 combination X, then P combination P to power X, and then this one will be 0.4 to power 10 minus X. So you can put this one at once on your calculator and compute. So if you have put it there, go to solve. It brings your X equaling to If it brings x equaling 2, we press the first one is 8. So when you press 8, it will give you 0.12093 and so on. So that will give us 0.1209 to 4 decimal places. Then put your x equaling to 9. So your x equal to 9, then press equal signs. It will give you 0.04031 like that. So 4 decimal places, we shall get that. And lastly, put x as 10, then press equal signs. It will give you 0.0060466. So it will give us that. So compute that one and see if it will give you this answer. So that is a 0.1672. So we shall have 0.1209. We add there 0.0403. We add there 0.0060. It will give us 0.1672 as the answer. So that will be the required answer. So that is part 2. So we had 2 parts only, part 1 and 2. So part 1 is done, and also part 2 is also done. So next we can look at example number 3. So in example number 3, they are saying the probability that a marble drawn at random from a box is red is 0.4. So probability of getting red is 0.4. So if we are having a sample of 6 marbles, then find the probability that it will contain one no red marble. So for this case, interpreting this question here, we have our P, since we are dealing with probability of drawing a red marble at 0.4. So our P is 0.4. Our sample, that is N, is equal to 6. So you can easily get Q. And Q will be 1 minus 0.4, which is 0.6. Then for part 1, we need from this sample to get no red marble. So it means that is a probability of X equaling to 0. So probability X equaling to 0. So you can easily get that by substituting. That is 6 combination 0 times P to power R, which is 0, then times Q to power 6 minus 0, which means 6. So we shall be able to have this. So place that one on your calculator and see if you are getting the same answer as 0.0466. So when you press 6 combination 0 times 0.4 to power 0 times 0.6 to power 6, you should be able to get 0.046656. So that will be able to give us a 0.0466. But because of that 5, someone can round it off. But since this is an even number, that is 6 is an even number and followed by 5, so we shall maintain that one as 6. So that will be 0.0466 as the answer. Then next, 5 or 6 red marbles, probability of X equaling to 5 or X equaling to 6. So for part 2, probability of 5 or 6, that would be same as probability of X equaling to 5 plus probability of X equaling to 6. So looking at that, you also substitute. So probability of X equaling to 5 is 6 combination 5 times 0.4 to power 5 times 0.6 to power 1. Then as this one here, probability for that 6 combination 6 times 0.4 to power 6, then times 0.6 to power 0. So when you put that on the calculator, you'll be able to get, for this one here, when you press it, you'll be able to get 0.036864. So which will give us this. Then for that next one, when we put that one there, 6 combination 6, then 0.4 to power 6, then 0.6 to power 0. So that will give us 0.04096. So that will be 0.00041, and that will be the value. So when you add that 0.0369, you add it to 0.0041, you'll be able to get a 0.041. So that will be the required answer. So part 3 requires us less than half red marbles. So half, first of all, there are 6 of them. So less than half of the 6, that is less than 3. So that is the probability of X less than 3, less than half of red marbles. So we are choosing from a sample of 6, so we are looking at less than X equaling to 3. So that is probability of X less than 3. So probability of X less than 3, we have probability of X equaling to 0 plus probability of x equaling to 1 plus probability of x equaling to 2. So likewise, we shall try to manipulate this. So probability of x equaling to 0, probability of x equaling to 1, and probability of x equaling to 2. So put it in the expression for binomial distribution. So it will be 6 combination 0 times 0.4 at the power 0 times 0.6 at the power of 6. Likewise, for p of x equaling to 1, it will be this. For p of x equaling to 2, it will be that. So try to get the value for this, get the value for this, get the value for that. So when you get those values, you should be able to confirm that the probability of x less than 3 will be equal to 0.544, and that will be the required answer. Please make sure you put these ones on the calculator, and you confirm these answers. So confirm whether what we are getting here is the same value you are getting from your calculator. And lastly, we shall come to example number 3. Example number 3 says a box contains a large number of pens. The probability that a pen is faulty is 0.1. So how many pens would you need to select? To be more than 95% certain of picking at least one faulty pen? So that is what we need to talk about. So this we shall try together. We are given that a box contains a large number of pens. The probability that a pen is faulty is 0.1, but we need the number of pens we would like to draw such that we are more than 95% certain of picking at least one faulty pen. So according to this, we are dealing with faulty pens, and the probability of picking a faulty pen is 0.1, which means that our P, the probability of success, our P will be 0.1. Our Q will be 0.9. That is 1 minus the answer. So here we are talking about x. So our x follow a binomial distribution with the number of pens we don't know, but the probability of success is that this x here is the number of 40 pens. It's the number of 40 pens. So we are dealing with 40 pens. It's the number of 40 pens. So what we are interested in is to get the value of n such that we are more than 95% certain of picking at least 140 pen. So at least 140 pen. So what we want is a probability of picking at least 140 pen to be more than 95%. That is 0.95. That is exactly what we need. They're saying how many pens would you need to select to be more than 95% certain of picking at least 140 pen. So that is the probability of picking at least 140 pen should be more than 95%. So this is exactly what we need. So now, if we have probability of x greater or equal to 1, this can be also same as having probability of x greater or equal to 1 is same as having 1 minus probability of x less than 1. This is same as 1 minus probability of x less than 1. And this value should be greater than 0.95. Now, looking at this, this is same as 1 minus probability of x less than 1. Of course, that is same as probability of x equaling to 0, which should be greater than 0.95. Now, from this, what is a probability of x equaling to 0? This is same as any combination by binomial distribution. Any combination 0 times p is 0.1 power 0 times, let me use multiplication, times 0.9 to power n minus 0, that is n. And this is greater than 0.95. So this is 1 minus any combination 0. So any number combination 0, it will give you 1. If you try, for example, 9 combination 0, 9 combination 0 is 1. 10 combination 0, 10 combination of 0, still it will give you 1. So any number combination 0 is 1. So this is 1 times 0.1 to power 0 is 1 times 0.9 to power n must be greater than 0.95. So this is 1 minus 0.9 to power n greater than 0.95. Okay, so looking at that, we can try to bring this one to the other side. Negative 0.9 negative 0.9 to power n is greater than 0.95 minus 1. So negative 0.9 to the power n is greater than. So you get a 0.95 subtract 1, you get negative of 0.05. That is what we shall have. So divide this through by a negative, this becomes 0.9 to the power n. If you divide it through by a negative, this changes, the sign changes, so it becomes less than now, 0.05. That is what we shall have. Now from this given point, I am interested in n. I'm interested in n, so take logarithm on both sides. So logarithm of 0.9, this is 2 power to base 10. So of n is same as logarithm of 0.05. So this will be n log 10 of 0.9, which is same as log, and this is also 10, so 10 of 0.05. So from here, you will divide through by log of 10. So dividing through by log 10 of 0.9, so this will be n greater than log 10 of 0.05 divided by log 10 of 0.9. You may ask, why is this one changing? Log 10 of 0.9 from the calculator, log of 0.9 is a negative value. So whenever you divide by a negative value, like the way we did here, dividing through by negative, so the sign changes. Likewise, if you are dividing by this value here, if you get this value from the calculator, it is a negative. So you are dividing through by a negative value. Though here is log of 10 of 0.9, you may see it as if it is not a negative value, but here you are dividing by a negative value. And when you are dealing with inequalities, the moment you divide by a negative value, the sign does change. So that is why we have done this. If you want to see it well, you can look at this. This is same as n times what is log of 0.9. It is negative 0.04557. This is less than what is a logarithm of 0.05. Still is also minus 1.301 something. So you realize that here you are dividing by negative of 0.045 on both sides. So when you divide by negative, then this sign will change. That sign will change. So that is the reason that's why we are doing that. So you have to be careful, especially when you are dealing with logarithm, and here you are dividing by a number which is negative. So our n will be greater than, so let us get that logarithm of 0.05 divided by logarithm of 0.9. So that will give us 28. So our n will be greater than 28.4316. So for that case, this therefore implies that the maximum number, this therefore implies that the minimum. So the minimum number of pens that can be drawn, such that we have, or we are sure or certain that the probability of picking at least one 40 pen, will be n equaling to, so the next integer number here is 29. So it will be 29. So this will be the minimum number of pens that can be drawn, such that you are certain of having at least one 40 pen, and that will be the answer. So our n is equal to 29. So that will be the required answer. So that will be the answer, and those will be the examples that we shall look at. And here are some of the questions for you to try out. Remember, whenever these questions are left, please make sure you try them. Try as much as possible to get the answers to these questions. So here we have got many questions. So make sure you give them your time. So try them. Try these questions. So we have question 1, 2, and question number 3 here. Make sure you copy them, try them, and from here we have a question, also question number 4. We have question number 4 as well. And next we have these questions from 5 up to 6. From 5 up to 6. So next we have 7 8, question 7 and 8. Make sure you pause the video and get these questions well. So 7 and 8. And we have question 9 as well. So next we have question 10 and 11. And those are the questions that you will try out. So this will mark to the end of our today's lecture. Please don't forget to hit the like button. Don't forget to subscribe to this channel. And don't forget to share this video to all your friends.
Yeah.